Hello, welcome everyone. Now we are going to solve a problem. You have three capacitors. Problem says you have three capacitors in which their capacitance are C1 is equal to 6 microfarad, C2 is equal to 9 microfarad, C3 is equal to 18 microfarad, and an 18 volt battery is connected to them. Draw the circuit diagram. Draw the circuit diagram. It says draw the circuit diagram. Explain how to connect these three capacitors in order to get a maximum amount of capacitance. Then find the stored charge in the group, and it says also find the stored energy in group. And now let's solve the A. And for the properties of series combination and the parallel combination, there is a formula for the equivalent capacitance. For the series combination, equivalent capacitance is equal to 1 over C equivalence is equal to 1 over C1 plus 1 over C2. And for the parallel combination, C equivalence is equal to C1 plus C2. If there is a third one, plus C3. If there is a third one, plus 1 over C3. And here in parallel combination, as you see, this is the sum of them. There is a division. There is no division. There is direct addition. There is a divisional addition, we can say. There is a fraction. There is no fraction. So this addition going to be more. So for the C equivalence max, we have to use parallel combination formula. And so to calculate C equivalence, it will be C1 plus C2 plus C3. So it will be 6 plus 9 plus 18. So the result will be 33 microfarad. They are all in microfarad. And now let's calculate the charge, total charge. Total charge formula Q total is equals to C equivalence times delta V. And C equivalence we calculated 33 times 10 to the power of minus 6 times delta V is equals 18. So it will be 33 times 18, 594 times 10 to the power of minus 6 coulomb. And also question says calculate the potential energy, stored energy. PE equals to half C equivalence times delta V squared. So it will be half times C equivalence 33 times 10 to the power of minus 6 times delta V is 18 squared. So potential energy, stored energy going to be 5346 times 10 to the power of minus 6, of course in joule. And for the A, also it says draw the circuit diagram. How can we draw the parallel combination? I forgot to say and to draw. Like that we can draw it basically C1, C2 and C3. And delta V is equals to 18 volt. B says the smallest amount of equivalent capacitance, then find the stored charge in the group and stored energy in the group. Also B says to us find C equivalence, but now minimum, and Q total is what, and stored energy, stored potential energy. So to obtain minimum equivalent capacitance, we have to use series combination formula. And its definition of the series combination, it describes it. It says the equivalent capacitance becomes less than the smallest capacitance. So we have to use this one. 1 over C equivalence is equals to 1 over C1 plus 1 over C2 plus 1 over C3. So it will be 1 over 6 plus 1 over 9 plus 1 over 18. So I will expand this with 3, with 2, and with 1. So it will be 6 over 18, and it equals 1 over C equivalence. And it will be, from here, if we use the cross multiplication, it will be what? 6 times C equivalence is equals to 18. So C equivalent will be 18 over 6, 3 microfarad, we can say. And so we have C equivalence, we calculated. As you see, it is less than the smallest capacitance. And now let's calculate the Q total. Q total is equals to C equivalence times delta V. C equivalence 3 times 10 to the power of minus 6 times delta V is 18 is equals to 54 times 10 to the power of minus 6 column. And potential energy, stored energy is equals to half times C equivalence times delta V squared is equals half times C equivalence 3 times 10 to the power of minus 6 times 18 squared. So the result will be 486 times 10 to the power of minus 6 joule, of course. And let's draw the circuit diagram of it. If we draw the circuit diagram, it will be like that. Delta V is equals to 18. This is the first, second, and third capacitor, C1, C2, and C3. This is the series combination, and this must be 18 volt. Thanks for listening.